In this video, we will talk about the center limit theorem. Um, Recall we are talking about x bar. So remember again, x bar is the mean of the sample, right? X bar is the mean of the sample, and mu is the mean of the population. So it's the average of the population. For example, we are trying to find the average height of Özyeğin University. It's impossible to find it. So what we do is we take a sample and calculate x bar. X bar will say something about mu. We will infer information about mu through x bar. Right? So please note that the main difference between mu and x bar is, well, mu is what? Mu is constant, right? So for example, assume uh, mu is constant and x bar is is what is changeable. It changes from class to class. So let's give an example like this. Let's assume this is Özyeğin University. This is my class. This is, let's say, Erinç Hoca's class. This is Özcan Hoca's class. So if you go to here and calculate the x bar in this class, then x bar is something different. Let's say this is x bar 1. For example, let's say this is 172 centimeters. If you go to Erinç Hoca's class, then it will be something like 174. I'm just making up. Uh, if you go to Ersan Hoca's class, it will be something like 166, 76. Okay, so it may be the case that all of them can be different because there are different students in this class. At least, although some may be in common, there can be different students in each class. So X bars will be different, right? However, mu mu is the average of Özyeğin University, right? So mu is the same everywhere. So mu is the average of all of the students in Özyeğin University. So mu, if you're talking about mu of this class, then, well, it's not mu of a particular class, but it's mu of the population which this class belongs to. So mu here is equal to the mu here, and it's equal to the mu here, right? So mu is constant. It doesn't change from sample to sample, but x bar changes from sample to sample. In fact, x bar, well, x bar, remember, that's equal to what? X1 plus dot 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 xn divided by n. And each x is an observation in the sample, which is, remember, this is uh, um, so in order to be a sample, this should be independent and identically distributed, which means each of x1, x2 comes from the same distribution, the same distribution. So each of them is a random variable, right? Each observation is a random variable. And what you do is you just take the average of a random variable. So this is a function of a random variable, and the function of a random variable is a random variable itself, right? So x bar is a random variable. Okay. So just like all random variables, it has a mean, right? So it has an expected value of x bar, it has a variance of x bar, and it has a distribution f of x bar, right? If I'm able to find these, then it will be it. I will say um, I will say more about the unknown parameter mu. Right? So again, please, this is the population, Özyeğin University. Its parameter is mu. I don't know this, right? I don't know this. In order to calculate this, I take a small sample, which is x bar. I can calculate this. Mu is a constant because, well, it's the average of all of the observations, right? But we don't know it, but it's constant, it's there. However, x bar is a random variable because if you take x bar from this class, it's different than the x bar of the other class. So this is a random variable. Now, we will try to find its mean, its variance, and its distribution in order to increase the quality of the information that we infer from X bar about him. So we will first find the expected value of X bar, which is mu of X bar, right? So recall from your probability course, if x1, x2, dot, 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 xn are independent random variables with a mean mu I and variance sigma I, so there is nothing related to the distribution here, okay? We are just talking about their expected value and variance. Then expected value of a scalar times x1, another scalar times x2 dot 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 a and xn is equal to a1 times mu1, right? Plus a2 mu2 dot dot a n mu n. So for example, if you have two variables, 2 times x1 plus 3 times x2, and if it turns out that the expected value of x1 is equal to, let's say, 10, and the expected value of x2 is equal to 20, right? Then expected value of 2x1 plus 3x2 is equal to 2 times 10 plus 3 times 20, right? So since this is true now, remember what is the definition of x bar? It's equal to x1 plus x2 plus dot 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 xn xn divided by n. So this is equal to x1 over n plus x2 over n plus dot 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 xn over n, right? Hence, expected value of x bar is equal to what? It's equal to expected value of x1, right, divided by n, dot, 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 expected value of xn divided by n. And what is the expected value of x1 or xn? Well, we know that uh, x bar, right, is equal to x1, x2, dot, dot, xn, sum of them divided by n. And these x's comes from the same population, which means their distribution is same. Their mu and their sigma square are the same. So this is equal to, in fact, what? Mu over n, n times mu over n, which is equal to mu, right? So the expected value of x bar is equal to mu, right? Um, okay. So what does this mean? What does this mean? Um, so okay. Now let's try to visualize it like this. So, in order to find the expected value of the heights of the students in Özyeğin University, right? What you do is, well, there are, I don't know, 30,000 or 10,000 many students here, right? Just take the average of them. So just take everyone and take their average in order to find the real mu. So how can you find the expected value of X bar? Just try to think about something like this. So, for example, one way is um, assume we are trying to find the expected value of an x bar, right? So I have to give an n. Let's assume I'm trying to find the value of an x bar where n is equal to 30, right? How to find this? Well, what you can do is you can just go to a class of 30 students, calculate their x bar, and let's say this is x bar 1. Go to another class of size 30, calculate their x bar, which is x bar 2. And like this, go to as many classes as you can with a population of 30. Okay, so this is again an x bar. Let's say you just go to, I'm just making it up, 1,000 many classes. Okay, 1,000 many classes. All of them are all of them are of size 30. Then if you just take the average of them, okay, x1 bar plus dot 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 x bar 1,000 divided by 1,000, then since this is a very large number, you will be able to find what? The expected value of x bar. So, well, this is the average of this class, this is the average of this class, and you're finding the averages of averages. So it's intuitive that, well, that's equal to mu, right? So how about the variance of x bar? Again, from your probability course, remember that, well, a1 x1 plus a2 x2 dot dot an xn, well, the variance of them is equal to a1, so you just take square and square of, sorry, not square, but the square and then multiply by the variance square, a2 square, sigma 2 square, and so on and so forth. So remember what is x bar? X bar is equal to x1 dot 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 xn divided by n, which is equal to x1 over n plus dot 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 x x what xn divided by n. So this is equal to all of the variances are the same. All of the variances are the same, which is sigma square. So this is equal to sigma square, not one, sigma square divided by, you should take the square of this, n square. How many of them you have? You have n of them, okay? So these cancel, and this is equal to sigma squared divided by n, right? So the 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 variance of x bar is equal to what? It's equal to sigma squared divided by n, right? So what does it mean? It means that, well, if you're, for example, for Özyeğin University, if your height x, let's say, is distributed, for example, let's say normally, if it is distributed normally with mean mu and with sigma square, okay, or let me just do it like this, or let's say it like this. Um, For example, if the height of the students in Özyeğin University is normally distributed with 170 centimeters and with a standard deviation of or variance of 100 or standard deviation of 10 centimeters, okay? And then assume you are talking about an X bar, the average of a class where n is equal to 100. So you are talking about a class of size 100. Then, well, this is a random variable, okay? Because if you go to one class and ask their height and take the average will be different than another class of size 100, okay? So each of class has different X bars, right? Remember the discussion? So how to find, so what did we find? We said that, well, X bar, okay, so for X bar, expected value of X bar is equal to what? It's equal to 170 because it's the same with the mu of the height of the students, right? How about the variance of x bar? The variance of x bar is equal to the variance of x, which is 10 square. I'm just writing 10 square in order to show that this is sigma square, but not sigma, right? Sigma square divided by what? Divided by n. Okay, so this is equal to 100. So this is equal to what? 1. So the variance of x bar is equal to 1. And the standard deviation of x is equal to what? That's equal to 10. And the standard deviation of x bar is equal to 1. See? So, well, if x has a mean of 170 and a variance of 100, then x bar, which is a class of size 100, will have an expected value 170 and it has a standard deviation of 1. Okay, so the variance of x bar becomes smaller and smaller and smaller if you take a larger n, which means if you take a larger sample, which means in terms of our height example, you take a class of larger sizes, right? So, okay, we find the mean of x bar, which is mu. We find the variance of x bar, which is sigma squared divided by n. How about the distribution? Right? So, well, we have a great result. The center limit theorem. The center limit theorem says that, well, if x bar is the mean of a random sample of size n, taken from a population with mean mu and the finite variance sigma square, then the limiting form of this distribution, okay, is the standard normal distribution, which means you have a normal distribution with 0 and 1. Or in another words, it says that, well, x bar is normally distributed, approximately normally distributed, let's say, with mean mu and with standard deviation sigma divided by root. And remember, this is sigma, the variance was sigma squared divided by n, and the standard deviation is sigma divided by root n. Okay, so this is an approximation. As n goes to infinity, well, this is correct. Okay, this approximation is better. But the general rule of thumb is if n is greater than or equal to 30, this approximation works very well. Okay. Well, that's a great result. What does this mean? It says that, well, um, it doesn't depend on the distribution of x. It doesn't depend on the distribution of the heights. Your heights can be uniformly distributed. Your heights can be exponentially distributed. Your heights can be gamma distributed. Your heights can be beta distributed, and so on and so forth. Whatever the distribution of individual heights are, right? The distribution of x bar in terms of our example, the distribution of the Average of a class is what? The distribution of average of a class is normally distributed. That's a great result. Okay, okay, let's stop here and we will continue at the next video.